In this section, we're going to look at some standard results for the positions of centers of mass. Some of them are fairly obvious, and you'll be expected to know them. Others are much less so, and if you're asked to use them, you'll be given them either in your paper or on the formula booklet. The first shape we're going to look at is the rectangle. Quite clearly, the center of mass of a rectangle is at the center. This means it will be halfway along this side and halfway along this side. The circle is also fairly obvious, being at the center of the circle. A triangle, however, is more complex. If we take a line from a vertex to the midpoint of the other side, so it's at the midpoint, such a line is called a median. This is one of the median lines for this triangle. If we take another median line, so it will go to the midpoint of this side, and also the third median line, they all meet at a point. We can see the point here. The center of mass will be at this point where the three medians meet. When locating the center of mass for a given triangle, a fact that is useful is that if we call this point A and this point B, AM is equal to 2/3 of AB. Therefore, if we know A and B, we know that M is 2/3 of the way from A to B. So we only ever need to work with one median when locating the center of mass for a triangle. If we have a rod and it is uniform, i.e. its density is the same along its length, then the center of mass will be located at the midpoint of the rod. The uniform circular arc is the first of two more complex results that we need to discuss. Note the angle at the center of this arc is 2 alpha. Imagine that this is a piece of wire bent to form a circular arc. Clearly, by symmetry, the center of mass must lie on this line that bisects the angle. The center of mass will be somewhere along this line. The position of the center of mass is given as r times sine alpha divided by alpha from the center. The center is here, and alpha, and note that this is alpha in the formula, not 2 alpha, the angle at the center of the arc. Alpha must be in radians. The uniform sector is the second of our two more complicated results. Once again, note the angle at the center is 2 alpha. By symmetry, our center of mass must lie along this line. we want to know the position along this line of our centre of mass. Let's suppose it's here. The formula this time is that it is at 2r sine alpha divided by 3 alpha from the centre. Here is the centre. Once again, alpha must be in radians, and both of these last two results will be given to you if you're expected to use them.